So now we're going to look at problem 3.3. So we've got a multi-compositional system. So it's telling us compute the composition, weight fraction, composition, and volume fraction of a gas with the following compositions. So if you look, we've got a list here of 5 components. Here's the mole fraction composition. We really don't get much details, but it's telling us it's a gas. So if it's a gas, if you actually look, basically the volume fraction of a gas, if you remember back to Dalton's law, I believe it is, volume fraction of a gas is really going to be the same as mole fraction. So you basically have the answer. Here's the volume fraction. So 87% of the volume is methane in this system. However, weight fraction is a total different calculation. For that reason, this is one of those that it's worthwhile to go ahead and pull in and work in Excel. So I'll get the Excel sheet in here. So I already pre-filled this out with the table that's in the problem here. So we got our components. Here's our mole fraction. We call this Y sub j because it's a gas. Is Y, j is just the component number. So Y sub 1 would be this 87%. And went on into the back. If you go in the back table, I guess I can show you that back in the appendix. This is the very first chart in the appendix. If we came here and say I zoom in, so here's methane. This is table A1 in the appendix. Here's methane. Here's a molecular mass, 16.043. So it's showing 16.04 because I've got 2 decimal places. I'll show you. Basically, you can put these values in one time. So 16, 30, 44, 58, 1, 2, 3, and get those values. So now, what are we trying to calculate next? First of all, we need to get the compositional weight fraction. And so if we look, we're going to multiply Y sub j times m, the molecular weight. We're trying to find the overall composite molecular weight value of this mixture. This is going to be equal to that times that, and then we can just copy these down. And so this is the component of the molecular mass made up by this gas. So if we come down here, I want to say MA, this is the, let's call it that. This is the composite molecular mass of this mixture. That's going to equal the sum of this column there. So this is our composite. So our sample of gas has this composite molecular weight made up by each one of these components. So that's good. That's the overall. Now I want to see each weight fraction. So if you want to say weight fraction, and I want to see the weight fraction, all that is this value divided by the overall. So it's how much of the total mass is made up by each component's mass. So there's the answer to that. If I come and drag this, I got to make sure that this stays the same value, so I can put my dollar signs here. That will hold this value tight. I'll show you how that works. I'll drag this down. So you can see this held that value and allowed this one to move. So there's the weight fractions of each component. And you could turn that into percents if you wanted to. So 70%, 71% of the weight of this mixture is methane. 87% of the volume. And that's the solution to this problem.